Hi. Today we're going to take a look at starting sequences and series. And the first thing we're going to look at is what we call a sequence. And we want to know if a sequence diverges or converges. Now, basically what a sequence is, it's just a list of numbers. That's all it is, a list of numbers. For example, I can have the following list. 1, 2, 3, 4, and so on and so forth. That's a sequence. I could also have another example. I could have something like 1/2, 1/3, 1/4, and 1/5, and so on and so forth. These are both considered what we call sequences. And yet, even though they're both sequences, they're a lot different from each other in terms of what we call convergence and divergence. Now, convergence means that if I go on forever and ever and ever and ever, my sequence is going to approach a number. So that's what convergence means. Divergence means if I go on forever and ever and ever, off to infinity, we're not approaching a certain number. It diverges. So it's the opposite of convergence. So we're going to take a look here. And if I look at these two examples right here, like the 1, 2, 3, 4, the 1/2, 1/3, 1/4, and 1/5, I can easily kind of tell if I go off forever, this just goes off to infinity. So we say, therefore, this sequence diverges. Now, over here, we have 1/2, 1/3, 1/4, 1/5. As we go on forever, as we approach infinity, the bottom is getting really big. Therefore, as we know, if we take a small number like 1 divided by a really big number, we get 0. Therefore, this series converges. And it converges to 0. If we go off forever to infinity, the very last number is going to be 0, kind of like that. So we're not going to spend too much time here today talking about what a sequence is. If you want to know what that is, I do have a video on it. It's a lot earlier, so just scroll back on my video feeds and you'll be able to see some. But what I want to talk about today is how do we tell if a sequence converges or diverges. So how to tell if a sequence converges or diverges. And it's a very simple test, and it is considered a test. We're going to take the limit as we let the number of terms go to infinity. That's what we're going to do. We're going to take the limit as n goes to infinity. We let n get really big. Okay? Like here, if I let n get really big, like this is my number, my first term, my second term, third term. As we let that term get bigger and bigger and bigger, this went off to infinity, it diverged. Whereas this one, as we let this bottom term get really big, it went to 0. It converged. So we're going to take the limit. And here's kind of the rule. If we get a number that is finite, we say the sequence converges to that number. We'll talk about that in just a second. Okay? Moment. If the limit is not finite, in other words, you get infinity or some other weird thing, we say the sequence diverges, and we just leave it alone. So let's take a look at an example right here. Let's say we have a sequence. Remember, we always write a sequence as something like a to the n. So let's say we have the sequence a to the n, a sub n equals 8 plus 5 over n. And I want to know if this sequence will converge or diverge. Well, I can kind of list them. The first one is going to be like 8 plus 5. I get 8 plus 5 halves. I get 8 plus, 5 thirds. 8 plus 5 over 4. 8 plus 5 over 5. 8 plus 5 over 5. And if you notice, what's happening is the second number. Here, when I add 8 plus 5, I get 13. Here I get 8 plus 5 over 2, which is 10 and a half. Here I get 8 plus 1 and 2/3, so 9 and 2/3. 8 plus 1 1/4, 9 and 9 1/4. Here it's 8 plus 1, so I get 9. What's happening, the 8 stays the same, but this 5 over n is changing. It's getting smaller and smaller and smaller. Well, eventually we can kind of think it over. This term right here goes to 0, and what we're going to be left with is the number 8. Now, if only calculus was that simple. We just can't use common sense in calculus. We have to kind of prove it. So to do that, what we're going to do is we take the limit as n goes to infinity, of our problem. 8 plus 5 over n. And if I plug the infinity in here, well, 5 over infinity is one of our definitions. That's just 0. So I get 8 plus 0, which is 8. So we say, therefore, the sequence converges to 8. Because why? 8 is finite. Now, even better, now series this doesn't work, but in a sequence, take a look. As this gets smaller and smaller and smaller, I'm stuck with the 8. The actual last number in my sequence will appear to be 8. It's asymptotic, but it's like 8.0 plus a billion infinity zeros there, and then followed by a 1 at the end. So it's basically 8. Number 2, let's take a look at another one here. What if we have something like a sub n equals, let's say this, n squared over, let's say n squared plus 3. Now this is a lot harder to kind of imagine it, but that's where we have the limit process. So what we do is we take the limit as n goes to infinity. I get n squared over n squared plus 3. We should recognize this from earlier. My coefficients are the same, so I just look, so that's all I really care about. So this is really saying the limit as n goes to infinity of n squared over n squared, which is just 1. So this approaches 1, and since 1 is finite, we say, therefore, this sequence converges to 1. Now, you have to have the phrase is finite there, because you're telling the reader in the AP test that, yes, you know that because 1 is a finite, that my rule tells me this will converge to 1. For number 3, let's try another one here. All right, let me see here. Oh, this is always a fun one. What about a sub n equals something like, let's do n plus 2 factorial over n factorial. Now, we haven't done much with factorials in calculus, but the idea is kind of still the same. Now, we can kind of imagine this one. As n gets really big, the top is always going to be bigger than the bottom number. So we know what's happening. The top is going to get bigger faster than the bottom. So this is going to shoot off 2. This is going to become infinity. This should diverge. But how to show it? Well, when we take the limit as n goes to infinity, what does it mean to be factorial? That means we can take this n, like it was 5 factorial, right? We would go 5 times 4 times 3 times 2 times 1. Well, what we're going to do is we're going to expand the bigger one. I'm going to expand the n plus 2 factorial to n plus 2, n plus 1. I just subtract 1 each time. And next I'm left with the n. Well, that's the same as my bottom, so I'm going to stop there and just write that as n factorial over n factorial, and those cancel. And what I'm left with is the limit as n goes to infinity of n plus 2, n plus 1, and if I let n go to infinity, I get infinity. This is not finite. Therefore, we can say the sequence diverges this time. So these are very easy to do. Let's take a look at a slightly harder one, number 4 here, if we could. All right, might have to refocus that, hopefully. Got it. All right, so let's try this one. What about a sub n equals something like n sine of 1 over n? All right, so if we take a look here, if I take the limit, I'm going to take the limit as n goes to infinity, and I'm going to get n times the sine of 1 over n. Now, if I plug my infinity in, I'm going to get infinity times, now if I plug infinity in here, this becomes the sine of 0, so I get infinity times 0. Now, you may recall we can't have infinity times 0, therefore we have to use L'Hopital's. Oh no, L'Hopital. So when I rewrite this one, I get the limit as n goes to infinity. I'm going to get this sine of 1 over n over, and I'm going to put this as 1 over n. That's n to the negative 1. Now when I plug it in, I'm going to get 0 over 0. Using L'Hopital's rule, remember we have to get into the correct form first. Using L'Hopital's rule, I take the derivative of the top. I'm going to get cosine 1 over n times negative 1 over n squared. On the bottom, If we plug this in, which I would say to do at the bottom, we get negative 1 over n squared. Those cancel, and we're left with the limit as n goes to infinity of cosine of 1 over n. And now if I plug it in, we get the cosine of 0, which is 1. Now, 1 is finite. So what does that tell us? Therefore, this sequence converges to 1. So what we're really going to do is we're just going to take the limit as n goes to infinity. Now, if you go to part 2, I'll take a look at a couple more examples with you, and you guys can go ahead and just a few more things to get some practice on, okay? See you then. Bye.